Our statistics lesson 3 is going to be focusing on the idea of standard deviation. So mean, median, and mode, while they're super important to talk about the middle of a curve, especially one that's normally distributed, it's important to not only know where the middle is, but also how spread out our data is from that middle, right? Is everything gathered really close to the middle? Is it spread out super wide? Right? That's going to tell us a lot about our curve shape as well. This is where the idea of standard deviation comes into play. So standard deviation, the definition of it, is it's a measure of the dispersion of data, right? How much the data is spread out, the dispersion, in relation to the mean. And so because we're looking at normally distributed curves, that's also in relation to the median and the mode, because those should be right in the center, right? The peak of our graph. So we'll look at a few graphs here, a few histograms, right? They're all in relation of frequency. The first one on the left, we see it's quite a narrow curve. It is normally distributed. It follows that bell shape, right? Low at the ends, high peak at the middle, right? Like a mountain. And so this is really, really clumped together, right? Our whole graph seems to be hitting between about 80 and 120 on that bottom x-axis, right? It's really clumped together. It's a very narrow bell shape. So this is something that has low standard deviation, right? It does not deviate very far from the middle. It is not very spread out from where we find that mean right in the center. The next curve, right, it's spread out a bit more. That peak is not quite as extreme because we see more of the data falling to the sides, right? It makes that same bell sort of curve low starting from the left-hand side. It gets higher around the middle, but see, it takes more time to spread out, right? There's more values. This one goes all the way somewhat between about 40 to 160 along the x-axis on the bottom. So this is about a medium standard deviation. And then this graph on the right, again, still normally distributed, right? We're still seeing that it starts low, peaks somewhere around the middle, and then tapers off at the end. But this one looks like it's spread out with values all the way from about 0 to 200. So this is something that has high standard deviation. The value of the standard deviation is going to be a larger value in this low spread out curve that goes farther on either side than the first graph where we have a high peak and all of our data is centered around a few values in the middle, right? 80 to 120. So the actual measure, right, it's going to be a value. It's going to be a numerical value. Is going to tell us how normal the data is in a normal distribution, right? And where all of that normal data falls. So the standard deviation of a normally distributed curve tends to follow this general rule of thumb. So within one standard deviation, right, if I go down by one standard deviation and up by one standard deviation, whatever that numerical measure happens to be, the amount of data, the amount of values that fall in between those make up 68% of all of the data we've covered. So 68% of the data is within plus or minus one standard deviation. If I go a little bit further, if I then go an additional standard deviation left down to -2, right? And again, that's from our mean. If I had a standard deviation of 10, right, 68% of my data would be 10 points above the mean and 10 points below the mean. Within that 20-point range, I would have 68% of all of the data points I have. If I then go down another, so I'm 2 standard deviations below the mean. So in this example, if I was to go 20 points below the mean, below the average, and also 20 points above the average, 95% of all of the data that I've collected, so if I collected 100 scores, 95 of them would be within those 2 standard deviations. So plus or minus 2 standard deviations from the mean. And if I go a third standard deviation, So again, if I was to go 30 points below the mean and 30 points above the mean, again, your standard deviation is a numerical value related to whatever data you're gathering. 99.7% of your data would be within plus or minus, so going above 3 and also going below 3 from your mean standard deviations. So what that's saying is that within those 3 standard deviations, almost all of our data should fit within that, right? That's what a standard deviation helps us identify, right? Only a few points are going to be more than 3 standard deviations above the normal, above the mean, and only a very fraction of them might be below 3 standard deviations. So let's look at what an example of this might look like. So we've collected the data of 100 male heights in inches. We want to figure out the standard deviation, right? So basically, how far above that average height and how far below that average height do I have to go for me to say that 68% of these men, right, have a height that's within 1 standard deviation of the average. So we're going to get our Google Sheet, again, finding that on our D2L shell. You have the notes practice. Make sure you're logged into your EduCBE account. When you get that open, I'm going to pull mine up in another tab. You want to make sure you are making a new copy. So again, make sure you go File, Make a Copy. You don't want to request access because I won't let you access this because then you'll change the numbers for everyone. So make a copy, again, title it whatever, add it to a folder to stay organized. And then here is where we can start to do some of our calculations. So first things first, we want to make a histogram. We've done this before. Let's go through those steps really quick. All right, so selecting our data, we have 100 data points here all the way from A1 to A100. I'm going to insert a chart. I'm going to move this to the top. And so we have our histogram here. Already we can see that nice normal distribution. We're going to just adjust our bucket size. I'm going to make it a bucket size of 1 so we can really see that bell curve. So edit my chart, customize the histogram aspect of that, and a bucket size of 1. Right, so we really see that normal distribution. Doesn't look like it's too spread out, but it also doesn't look too clumped together. And so we're going to find that standard deviation. First thing, we're going to look at the mean, the median, and the mode to just really verify that, yes, this is normally distributed. Yes, the center is all 3 of those measures of central tendency. Remember, to find mean, we do average, and it was A1 to A100. Our median is equals median, A1 to A100, and our mode, A1 to A100. And so what we notice here is that our mean, right, the average height, if I took all 100 of these heights, added them together and divided by 100, right, if all 100 of these men were to be the exact same height, it would work out to be 70.5 inches. The median, so again, the exact middle height, looks like it's also 70.5. The mode is a little bit different, 71, but that's okay, right? It's still within that same range we're looking at. So this is generally normally distributed. So we want to find out now what the standard deviation is. Basically, how far below 70.5 inches and how far above 70.5 inches do I have to go until I have 68 of these 100 scores encaptured there, right? The majority is what we can say. Well, what we want to do is we want to use another formula, right? We don't know how to calculate this one by hand, and it's STDEV, right? Standard deviation. And again, I'm finding the standard deviation of all 100 of these heights. I'm going to give it a title. This is standard deviation. And it says 2.795539, right? Some big long number. Again, what does this mean? Well, essentially, this is telling us that if I go 2.8 inches above or below the mean, is going to have the majority of our data. It's going to hold specifically 68% of our data. So if we figure out what that is, if I say what is 2.8 centimeters below 70.5, so I find out that 70.5 minus 2.8 is 67.7. And then on the upper end, 70.5 plus 2.8 is 73.3. This tells us that 68% of these scores, or 68 out of these 100 men, range between 67.7 and 73.3 inches tall. All right, it's telling us that the majority of people are within this range in this specific study. All right, so that's what our standard deviation is. If I was to go 2 standard deviations above and below, so I was to go one further, if I did 67.7 and I subtracted another 2.8 inches, we're at 64.9. I take my upper end, 70.3, and I add another standard deviation, 76.1. That means that 95% of these scores, right, or 95 out of 100 of these scores range between 64.9 and 76.1 inches. If I look at the scores, if I look at the number of heights between 67.7 and 73.3 inches, right, I'll look here. Let's go between 67 and 80. I have 9 men, right? The frequency was 9. Between 68 and 69, I had 10. Between 69 and 70, I had 12. 70 to 71, I had 14. 71 to 72, I had 12. And 72 to 73, I had 11. If I was to add up all of those frequencies, it turns out that that tells me 68 of the scores. Right? So it looks like 68 out of these 100 men fall between, and we roughed it up a little bit, right, just based off of our bin range, between 67 and 73. Right, we're having the majority of the data show up in the middle. We go out a little bit further. Again, 95% of those values are going to be between 65, right? We can see right at the edge, most of our data falls between 65 all the way up to 76. There's only a couple of scores, right, outside of that. And beyond that, in this case, we don't really have any crazy outliers, but if we were dealing with a bigger sample size, we might end up with some scores, right, outside of that 99.7% range, outside of 3 standard deviations. So that's what standard deviation is telling us. Going back to our notes, we're now going to look at how we can use this measure of standard deviation to help us find out if a specific value is standard or not. Right, where it might fall, how many standard deviations away from the mean a specific value is. This specific thing is called a Z-score, right, or a Z-score, and it tells us how far away it is. Keeping in mind that when a Z-score of a particular value is positive, that's telling us that the value is larger than the mean. Right, so if I tell you something has a Z-score of 1, that's telling us that it is 1 standard deviation larger than whatever the mean is. When a Z-score of a particular value is negative, right, that tells us it is some number of standard deviations below the mean. right, then that value is smaller than the mean. It's smaller than average. The formula we're going to use is that the z-score is equal to the value. So that's the value we're trying to find, right? We're calculating the z-score of a specific value. And from that value, we subtract the mean, right? We subtract the average and divide it by how big each standard deviation is to tell us the z-score, to tell us how far away from the mean that is. You might also see it with these other symbols, x representing your value. This mu symbol represents your mean. And then divided by sigma. This is a lowercase sigma. This represents standard deviation, right? Just knowing that the mu symbol, that fancy u, is another way of writing mean, and the sigma is another way of writing standard deviation. Right? We're going to use the one with words for the most part, though. So, given an example, Chris Pratt is 74 inches tall. This is real. I Googled it. Determine the z-score of his height, right? So what is that asking us, right? In general, in statistics language, how much taller or shorter, but Chris Pratt's a pretty tall guy, than average is he? Right, that's what it's asking. When it's asking us to determine a z-score, it's saying, tell us how far away he is from the normal, from the mean. And talk about it in terms of standard deviations, right? In terms of where we know majority of the population falls. So we'll use our formula. The z-score is equal to the value. So that's the specific value we're looking at right now. That's that 74. As I write 75, that's at 74. I'm subtracting the mean, and this is based off of that study we had of 100 males where we said that the mean was 70.5. Divided by the standard deviation, we're going to go with that rounded 2.80 we had. So I do the math. 74 minus 70.5 gives me 3.5. When we divide that by 2.8, that gives us 1.25, right? So what does that tell us? That tells us Chris Pratt is 1.25 standard deviations above average. What that means is, well, we saw that one standard deviation above, right, and below got us about 68% of people, right? Chris Pratt is even taller than that. Chris Pratt is taller than the majority of people. He's not quite taller than 95% of people because he's not at 2 standard deviations above, right? But he's quite tall. Daniel Radcliffe, a slightly shorter famous actor, is 65 inches tall. Let's figure out how tall he is compared to the average, his Z-score. So he has a value of 65, so we're going to go Z-score equals, now our value is 65, right? That's what we're trying to determine. We're trying to talk about Daniel specifically here. The mean is still 70.5. Standard deviation is still 2.80. So when I do 65 minus 70.5, I actually get negative 5.5 divided by 2.8. Daniel Radcliffe's z-score is negative 1.96. So again, what does that mean? Well, because it's a negative value, it means he's 1.96 standard deviations below the mean. All right, so he's almost 2 standard deviations below the mean. He's just within that 95% range, right? So he's not a very tall guy. He is below the average, but again, he's still within 95% of that data. He's not a crazy outlier. He's not crazy short compared to too many people, right? So that tells us his z-score. So you now have an example. You can work through the second tab on that practice sheet talking about average female height. And you can also complete assignment 3. So again, make sure you're finding that assignment, submitting it, saving your work as a PDF so that we can see your graph. And if you have any questions, again, drop by your teacher's virtual class, drop by their tutorials, email them any questions. And I hope you are feeling good about this topic of standard deviation and z-scores.